Hi, everybody. This is going to be a little screencast about how to calculate molarity and solve a molarity problem. Molarity is a way to express the concentration of a solution. And so we want to learn a little bit about that today as we're going to work with solutions a lot this year. Now, solutions, remember, are homogeneous mixtures, which means that they do not have a set formula. Um, because they do not have a set formula, we need a way to express the ratio of the parts that are in that solution. As you go through chemistry, you're going to learn that there's a lot of different ways. Like maybe, for example, you've seen on a bottle of rubbing alcohol at home where it'll say 70%. We've certainly seen on hand sanitizer where it will tell you the percentage of alcohol that's in that mixture. Maybe you've seen like on a vinegar bottle where it'll say 5%. Percentage is a way to express the ratio of the parts of a solution. And molarity is just another way to do that. Now, before we get into this a little bit today, I want to go over a little bit of vocabulary. So the solute is the substance that gets dissolved in the solvent. Like if I have a salt water solution, the salt is the solute. If I'm dissolving sugar in my iced tea, the sugar is one of the solutes. The tea is another solute because the solvent is the substance that does the dissolving, like the water in the case of salt water or the water in the case of my iced tea. Now, solutions can be dilute or they could be very concentrated because remember the ratio of the parts of a solution is not fixed or set, that can vary. So, a solution that is dilute has a really small amount of solute compared to the solvent. And then a solution that is concentrated, you have a larger amount of solute compared to the solvent. So if you have just a tiny little bit of salt in water and it tastes just a little bit salty, that would be dilute. And then if you keep adding salt and you would taste it, it would get even saltier. Same with like sugar, low amount of sugar, very little sweetener. It's a dilute solution. As you would continue to add sugar, it would become very concentrated. Now, you'll learn more about solubility later in a solutions unit in part B of this class, because there is a maximum amount of solute that can dissolve in a solvent. You know, at some point, if you keep adding sugar to your iced tea, the sugar just lays on the bottom. Or if you keep trying to dissolve salt in water, the salt will just lay on the bottom. So, but what we're going to talk about is when the solute does dissolve in the solvent and forms a solution, what is a way to express the concentration so that you can tell whether it's dilute or concentrated, and then also to kind of set us up with a number that we're going to be able to use in a lot of different ways this year in different applications. And that is a concept that's called the molarity. Now, molarity is the moles of solute per liter of solution. This really, in essence, kind of gives us an equation, because you can say that the molarity is equal to the moles of solute divided by the liters of the whole solution. So it makes a little equation that you can use. If you have two of the three variables, you can find the other one. And that's going to be our goal today, is manipulating that equation and then using it for one other purpose, as you'll see. So let's try some sample problems. Um, so this one, calculate the molarity of a solution containing 35 grams KCl and 750 milliliters of solution. So if you're trying to calculate the molarity, okay, you want to calculate that, you need the moles of the solute, which means we need the moles of KCl. And then we need to divide that by the liters of the solution. So we've got a little bit of converting to do. Like we've got to convert our KCl into moles. Now we know how to do that, fortunately. If you add the molar mass of the KCl, it is 74% 0.55 grams in a mole of KCl. And so we divide 35 by the 74.55. You do get a longer number. Keep at least the 3 sig figs. And I got 0.469 moles of KCl. When you're doing WebAssign, you might want to keep a few extras. I know in this particular case, it doesn't matter if you keep the extras or not, you're going to get the same answer. The 750 milliliters, that needs to be converted into liters. And we learned how to do that in the first unit. We know that 1 milliliter is 1/1000th of a liter. Oops, too many zeros. Adding an extra one in there when I'm talking. Hold on. Fix that. So can make that conversion and you should get 0.75. Now I'm not going to add a zero on the end because if you look back here, there's no decimal, which means that this is only 2 sig figs. So I'm going to keep it as 2 sig figs. But now I have my volume in liters. And when I divide, I get 0.63 molar is what they say. It has to be a capital M. Lowercase m is already used for meters. And then there's something else called molarity, which you'll learn in AP Chem if you take it. And that uses a small m. So it absolutely has to be a capital M. And it's usually proper to put what the solute is behind it. And there's the molarity of my solution. This solution is 0.63 molar KCl solution. Just another version, moving the unknown around a little bit. In this one, it says how many grams of KNO3 must be dissolved in 500 milliliters of solution to prepare, and then it gives you a certain molarity. This is really relevant. I know that when I make solutions for the lab, or if I have an intern, I have them do it. I always figure out like how much I think we need for all the lab groups in a lab. The lab will call for a certain concentration. And what I start with at the beginning is taking this equation that molarity is equal to the moles divided by the volume, and I multiply both sides by the volume. So I get molarity times volume is equal to the moles. Remember that because we're gonna use that for a lot of things later. So here I want to take my molarity 0.025 and I want to multiply by my volume, which again I have to convert that from milliliters to liters. Do it just like we did on the last one. This one I am going to put those zeros because with this decimal being right in there, this has 4 sig figs, so I need to add those 3 zeros. So when I multiply these two, I got 0.0125 moles of solute. Now you could round that off to 2 sig figs, especially with WebAssign. I'd keep the extra sig figs until the very end, and then I would round. I honestly think in this particular problem, again, it doesn't matter if you round now or at the end, you're going to get the same answer. But sometimes it does change your answer enough that WebAssign will mark you wrong. So this is a very common thing for us to do. Like, let's say I said to my, intern, like, hey, we need to make 500 milliliters of this. So what they do is do a problem like this right here. And then they go back and calculate exactly how much that's going to weigh by doing the mole to gram conversion. So you got to do a molar mass problem. And a mole of KNO3, I added that up, weighs 101.11 grams. And when you multiply that, you get 1.3, I'm taking it to 2 sig figs, grams of KNO3. So if I have an intern or if not, then I know what to do. I would go back to the lab. I would measure this much into a beaker. And then I would add water until the volume is 500 milliliters. And then I know that I have a solution of the correct molarity. So this is very useful, especially too in college. I know a lot of colleges have you make your own solutions. They just give you the solid and the equipment and have you calculate it, measure it, and make your own. And I'm pretty sure Mrs. Matthias in AP Chem has them do this a little bit to become better at, at making solutions, since that's a skill that you usually need moving on in chemistry. So, you can also have the variable be the volume. We did one where, in this one, where it was the moles and we converted to grams. We did the previous problem where the variable was the molarity. You could also know the moles and the molarity and calculate a volume, because there's three different variables in this equation. If you know two of them, you can always calculate the third one. Now remember this, okay? I had said, like, hey, we want to remember this equation, that molarity times volume is equal to the moles of solute, okay? This is an important concept because sometimes, and we're going to do this in the next unit, you can take what's called a stock solution, which is like a solution of a certain molarity, and you can add water to water it down and make a new molarity. Now, when you add water to a solution, you will change the volume, right? Because you're adding water, so it's going to have a bigger volume. And by adding water, you are diluting the solution. You're going to make a lower molarity. But this, the number of moles that's in that solution of solute, that's going to stay the same. When I add water to, like, let's say maybe I got some coffee that I think is a little strong, so I add some water. I haven't changed the amount of coffee that's dissolved in there. What I've done is changed the total volume and brought the concentration of my coffee down. So the moles of actual compound that's dissolved in there, the solute, that has stayed the same. And that's the key idea behind this. This equation is going to be a very handy equation. We'll be using this in a lab in Unit 3. And the idea here is that if 1 is before dilution and 2 is after dilution, that the moles before are equal to the moles after, right? Adding water and diluting the solution does not change the moles of the solute. So if we know the molarity and the volume before we dilute it, and we know the molarity and the volume after we dilute it, their products are going to be equal. And so what's nice is that if we have this equation, we can use this equation to figure out the new molarity of, any solution that we dilute. So let's do some examples like that. Like, for example, here, let's say, and this is definitely something that, again, I do, and then I have my interns do, measure 50 milliliters of 6 molar hydrochloric acid and add the acid, remember the safety, add the acid to the water. They add it to 250 milliliters of water. What's the new concentration? Now, with these, I usually suggest that let's figure out what we know, because the order that these things are mentioned in the problem, it's not always the first ones and then the second ones. I think in this one it is. But a student measures 50 milliliters. Okay. Now, it's kind of nice in this problem if one of them's in milliliters, they can just both be in milliliters, because if you convert them both to liters, you're like, they're still in proportion. So you can just leave it in milliliters. But if you want to put it in liters, that's fine too. 6 molar is the original concentration, okay? And they add it to 250 milliliters of water. So V2 is going to actually be 300. Do you see that? Because this and the water are added together. Now you got to really listen or look closely at the wording, because sometimes some of these problems say, like, take 10 milliliters of this acid and dilute it to 100 milliliters total in the end. Like, you really have to watch the wording. Here, it's clear that we have 50 milliliters of acid. We have 250, milliliters of water. Adding those together, that gives us 300.0 milliliters altogether. And so the thing that we don't know, it says, what is the new concentration of the HCl? So we don't know this. So now that we know what we are looking for, we can solve the problem. If I'm trying to solve for M2, I got to divide both sides by V2. So M2 is going to be equal to M1 V1 over V2. So plug it in, M1 6.0, V1 50, V2 on the bottom 300. So if I multiply those top numbers and divide by 300, that's going to give me my new molarity, which my new molarity is going to be 1.0. I need to keep 2 sig figs and a little bit of craziness there. Let me do this. Let's do this. So M2, here's my answer, is going to be 1. I need 2 sig figs, so I got to add the 0.0. And you should always add the label. It's molarity. And it is an HCl solution. So this is the new concentration of the hydrochloric acid. You're going to see some problems like that on the worksheet today and in WebAssign and in many future situations. So here's another one, just different wording, mixing up the variables. Let's mix it up. Let's mix up the colors. So this one says, calculate the volume of water you need to add to 5 milliliters of 18 molar sulfuric acid to reduce the concentration to 1 molar. Okay, so we know that M2, our new concentration, is 1 molar. The original concentration was 18. Not a fan of when that happens, sorry. So the original concentration was 18. And then we know that the original volume of this 18 was 5 milliliters. What we don't know is what's the new volume. Okay, so we're going to take our equation and we're going to solve for the new volume for V2. So this time we got to divide by M2, because that way over here it divides out. So our equation V2 is equal to M1 V1 over M2. So let's see, M1, 18. V1 is 5. M2 is 1. So, just looking at the units here, see how the M's cancel? So when I find this new volume, it is going to be in milliliters, not liters. Since I had V1 in milliliters, V2 is going to be in milliliters. So 18 times 5, divide by 1. I need 2 sig figs, so I get 90. Now, that's the new volume. The question, though, says calculate the volume of water you need to add to it. Okay? Actually, you should add the acid to the water, right? And so subtract out the original acid that was, already in the container, and I'm going to get 85. Now, we can't keep the 10th because we don't have a 10th in the 90 number, okay? But it's going to be 85 milliliters. That's how much water you would have to mix with the 5 milliliters of acid. Then you would get 90 milliliters of the 1 molar sulfuric acid solution. Okay. So what you're going to have today is taking this equation and the M1 V1 equals M2 V2 and using them to solve some problems. Okay. Good luck, and let me know if you have any questions. Trying to find my, there we go.